Hi everybody, this is your science teacher again, and we're going to talk a little bit more and have a little bit different look on chemical and physical changes of matter. So let's take a look at this here. So a physical change involves a change of state or form of substance while the chemical properties remain the same. Examples of physical change include crumpling a piece of paper. Look at this. So this is paper, right? Okay. Paper, you agree? Yeah. Okay, there it is, crumpling. All right. Is it still paper? Yes, it is. There's my coffee cup. Okay, wait a minute. Yeah, good coffee. Okay, so just because we crumple a piece of paper doesn't mean that it changes its chemical properties. We just changed its physical properties, okay? Examples of physical change: crumpling a piece of paper, paper melting, okay? Melting an ice cube, breaking a glass bottle, changes in the physical properties, do not produce new substances and are only concerned with energy and states of matter. So they do not produce new substances. Okay, here's solid to liquid. So you got an ice cube, turns into water. Okay, piece of paper that's crumpled. Okay, and a bottle that's broken. Okay, on the other hand, a chemical change takes place at the molecular level. So we're talking about inside these molecules, okay, or compounds. We're going to rearrange them. Okay, so we're going to, and it occurs when one or more substances are changed into new substances with different properties. Example of a chemical change include burning a piece of paper. So if I took this piece of paper right here and I lit it on fire, I'd have some ashes and I'd have carbon dioxide, and I'd have all kinds. I'd have different things. It would not be paper, would it? It would not be the same combination of things that make paper. Include burning a piece of paper into ashes, cooking an egg, rusting of iron, oops, we did that, and mixing an acid with a base to produce salt and water. Okay? Chemical reactions, and you can see here, chemical reactions occur every day all around you and even within you. Chemical reactions occur in plants during photosynthesis. That's when a plant takes in light and water and carbon dioxide, and it turns it into sugar, okay? And what else? Okay? And in the engines of automobiles, I talk about lots of times when I give you an example, a chemical reaction takes gasoline and turns it into, different substances. A chemical reaction is a series of chemical changes in which one or more substances, that's hard to say sometimes, are converted to one or more different substances. A digestion and respiration is a chemical change. Photosynthesis, combustion in a car. Substances are either chemical elements or compounds. An original substance that is involved in a chemical reaction is called a reactant. And we saw, up here where sodium and chlorine are the reactants, and sodium chloride or salt, is the product. It's a single product. Okay, so, and here's an example of, oxygen, water, carbon dioxide, sugar. So water and carbon dioxide are taken in photosynthesis. You can see that. The six carbon dioxide, compounds of carbon dioxide, molecules of carbon dioxide, and 6 molecules of water, okay? You need light energy, okay? And what happens? Chlorophyll in this process, and it turns into glucose or sugar, C6H12O6, and 6 molecules of oxygen, okay? And so substances are either chemical elements or compounds. An original substance that is involved in a chemical reaction is called a reactant, while the substance produced is called a product. Okay, and there is an example of a compound, and that looks like salt. Yeah, it is. Okay, evidence of chemical reactions. During a chemical reaction, atoms are can combine to form molecules. Molecules can break apart to form atoms or molecules, can react with other molecules to form new substances. So here you see a classic synthesis reaction. A plus B turns into AB. Okay, and that would be the example we use all the time is salt. Okay, now, so there is some other things, and that is, okay, and we're going to talk about something at a later time, but that's chemical reactions. Now we have a little bit more. Let's go over here and talk a little bit more on this. This is a really good book on chemical reactions. Chemists look for specific evidence to determine if a chemical reaction has taken place. This evidence can include the formation of gas, color change, formation of a precipitate, change in temperature, or emission of light. If one or more of these changes are observed and a new substance is formed, excuse me, then a chemical reaction has occurred. Formation of a gas, okay, color change, formation of a precipitate. Precipitate is a solid object within liquid usually, and a temperature change and light emission, which would be combustion, right? We're going to burn that. If we burn this piece of paper, we're going to get a light emission and we're going to get a temperature change, aren't we? Okay, chemical bond. A chemical bond is an attraction between the atoms that hold them together in a molecule. Okay, we know what a bond is when two things come together, right? During a chemical reaction, new substances are produced as the original bonds of the reactants are broken. And usually it takes heat or some other electricity or things to break it apart. Atoms are then rearranged and new bonds are formed between the atoms of products. For example, what happens when hydrogen and chlorine molecules are combined? The bonds that hold chlorine and hydrogen atoms together break, and then a new bond is formed between chlorine and hydrogen atoms. Okay, you can see an example there. Okay, so a new substance is formed. Okay, that's going to be the end of that particular one. We're going to get more into more detail on that as we go along. So I hope you enjoyed this. So I will talk to you soon. Bye.